Hello everyone, myself Shwetnisha. So today we are here with the another video of solving questions from previous year 2022, and right now we are only focusing on paper 1 subject by subject. So I have already discussed ordinary differential equations from paper 1, and today we are going to discuss next subject, which is analytic geometry. Okay, so without wasting any time, let's get started. This is very important. This is also important section of your paper 1, and it's easy also, so it's better that you don't miss in your preparation. So this is the basic structure of your paper. We have part 1, part 2, and the highlighted sections are from your from analytic geometry. This is question number 1 E part, question number 2 C part, question number 3 C, and question number 4 C. So we are going to discuss only these one. Also, you know very well that in question number 1, actually it's the mandatory section. So you can see there is a mandatory question from analytic geometry, right? So let's start with the first one. It was for 10 marks. And let's start. So what it says that a variable plane passes through a fixed point ABC and meets the axis at points A, B, and C respectively. Find the locus of the center of the sphere passing through the points O, A, B, and C, O, being the origin. Okay. So it passes through the points A, O, A, B, and C, O being the origin. So see, break down the question in parts, break down the question, and you try to write everything in mathematical expression. For example, if they are talking about plane here, you write equation of plane. Okay, so they have a given plane which passes through a fixed point. So I'll talk about this. ABC is a point where it passes, but it also meets the axis at ABC. They haven't talked about the points ABC. So let's start from here. Let given points A, B, C, they are P 0, 0, 0, Q 0, and what? And 0, 0, R. Okay, so these are 3 points respectively. If these are the 3 points, these are the 3 points from which the plane passes, then what will be the equation of plane? Equation of plane is given by, or you can say the equation of plane meeting axis at A, B, and C is x by P plus y by Q plus z by R is equals to 1. So that is your equation of plane, right? After that, about the same plane, they have given that ABC passes through that point, passes through that plane. It's on the plane. So that point will satisfy equation number 1. Since ABC lie on plane 1. Therefore, A by P plus B by Q plus C by R is equals to 1. Okay, that's the second. Let's move ahead. It says find the locus of center of sphere. We have to find locus of a point. That point is center of sphere, but I don't have equation of that sphere as well. So let's find out equation of that sphere also. What is general equation of sphere? Let equation of sphere. Right now, I'm not imposing any condition on it. It is just a general equation of a sphere. Let equation of sphere be x square plus y square plus z square plus 2ux plus 2by plus 2wz plus d is equals to 0. Now I'm going to impose the conditions one by one. So it's not any a sphere. It is a sphere that passes through these 4 points. So now I'm going to use these points one by one. If it passes through origin, I'll say this is the third equation. And since 3 passes through origin, therefore you substitute x, y, z everywhere 0. Left hand side should be equals to right hand side. Left hand side is d, right hand side is 0. So that means d is equals to 0. It also passes through a, which is a 0, 0. Right? What does that mean? Just substitute x as a and y and z be 0 and 0. So that is a square. Okay, sorry, that's not a, that's p, right? P comma 0, 0. So that's p square plus 2ut. All the terms that does not contain x vanish because y and z is 0. So that is equals to 0. You can find value of u from here. U is coming out to be minus p by 2. Okay. Next is, acha, similarly, see, it also passes through a, so that's why u is this. Similarly, v is equals to minus q by 2 and w is equals to minus r by 2 because 3 also passes through B and C. Passes through B and C. So now you have values of all the constants. Substitute in equation 3. So equation after substituting all these values, equation 3 becomes, now after substituting these values, equation 3 becomes, so we have d as 0, right? Other than that, u is minus p by 2, v is minus q by 2, w is minus r by 2. Let's substitute the values. I'll get x square plus y square plus z square. Because of that minus, I'll have minus 2 and 2 cancels, minus px minus qy minus rz is equals to 0. You see, I'm just showing you the first term. If I'll substitute in the first term, it will be plus 2 and this is minus p by 2 times x. So this 2 and 2 cancel and I'm left with minus px. Similarly, you'll get minus qx and minus rx, minus qy and minus rz over there. Now this is the equation of sphere. What we have to find? We have to find locus of center of the sphere. What is the center of sphere? If your equation of sphere is given like that in a general form, then minus of coefficient of x divided by 2. So basically in a general formula, I'll write it. It's like this. Center is given as minus coefficient of x divided by 2, comma, minus coefficient of y divided by 2, and minus coefficient of z divided by 2. Okay, that's your point. So calculate the center. Therefore, center is minus cancels, right? Coefficient of, so I'll be left with p only, p by 2. So it's p by 2, q by 2, and r by 2. See, whenever we want to find the locus of a point, this is the point. That means I need a relation between these values, p, q, r. Once I have the values, that means I'll change p by 2, q by 2, and r by 2 as x, y, z, and that will be my locus. So let's find the relation. You see, already in equation number 2, I have a relation between p, q, r. ABC is also allowed in the solution. Why? Because ABC are given in question itself, right? So that's the given variables. I can have that in my final answer. So you can use equation number 2. From equation 2, equation 2 don't have P by Q, P by 2, Q by 2, and R by 2. Instead, it has PQR. So I'll make it P by 2, Q by 2, and R by 2. How? See, I have A by P plus B by Q plus C by R is equals to 1. Now, I know that because I have to find locus of this point, that means I must see a P by 2 and I'll replace that P by 2 by X. So what I can do instead, I can just multiply 2 both sides. So if I multiply 2 here, I'll get A divided by P by 2 plus B divided by Q by 2 plus C divided by R by 2 is equals to 2. Okay. And then I'll just replace these with X, Y, Z. So what you will write at the end? Therefore, required locus is what? Is A by X plus B by Y plus C by Z is equals to 2. Okay, that's your locus. This is your answer. So what we have done, we have calculated, we have derived the equation of the plane that they were talking about, and we found a relation also because ABC was passing through that point, through that plane. So I got a relation also. That relation you can see is actually used later. Then we came to the second part of the question where they are mentioning about a sphere. And I started with the general equation of the sphere, and all the conditions that they have said, I've imposed it to calculate all the unknown variables into the terms of known variables. For example, ABC, right? We have in terms of PQR. And then from there, we got the center of sphere because we want to find the locus of center of sphere. Okay, that's why I got center of sphere. And then I know that what relation do I need? What are those expressions that will be replaced by X, Y, Z? So those relations are P by Q, P by 2, Q by 2, and R by 2. Okay, and that's how you get the locus. So this was for 10 marks. It was very easy question, and it was also from the book. Right? For analytic geometry, strictly you have to follow the book P.N. Chatterjee. This is also a question of P.N. Chatterjee itself. Now, jumping to the next question, as you can see clearly, it's for 20 marks. So next question says, this is from the section of ellipsoid. You should not leave any topic in analytic geometry. This comes at the end in conicoids. And I always say that in the class that in ellipsoid, please do the questions of 6 normals. There are like 6 to 7 questions in this topic in P.N. Chatterjee. You do not have to leave any question. Okay, and this is exactly one of the question of your P.N. Chatterjee again. Okay, let's start. If P, Q, R, P dash, Q dash, R dash are feet of the 6 normals drawn from a point to the ellipsoid disc, and the plane PQR is represented by this, show that the line, show that the plane P dash, Q dash, R dash is given by this plane. Okay, so what's happening here is, in ellipsoid, we have a concept of 6 normals. That means, let's say it's a 3D figure, so maybe I'll not be able to make it exactly, but I'm trying to make it. This is, let's say, this is ellipsoid. Like, this is how ellipsoid look. And there is a point outside, let's say P. Oh, no, okay, that cannot be P. Let's say A. A is a point. From that point, from a given point, 6 normals to the ellipsoid are possible. So maybe in the front side, one in the back side, and one over here, like that. Right? So total 1, 2, 3, 4, 5, 6. Right? So 6 normals are possible. All these are at 90 degrees to the surfaces. Okay. Those points on the feet means points on the ellipsoid are P, Q, R, and P dash, Q dash, and R dash. Okay. So out of those 3 points, they are saying out of those 3 points, as you can say, there are like, this is P, this is Q, and maybe this is R. And the other three are P dash, Q dash, R dash. So there is a plane that passes through these 3 points. There's a plane passing through these 3 points. You have to calculate the plane containing P dash, Q dash, R dash. Okay, that's your target. So let's, first of all, let's write what is given to me in a proper order. So about this A point, let's take that point to be something. So let given point, or let us say, let us consider point A to be x1, y1, z1, from which or from where feet of 6 normals are drawn to what? To ellipsoid. To ellipsoid x square by a square plus y square by b square plus z square by c square is equal to 1. Okay, and that is your first equation, given ellipsoid. Okay, after that, feet of the normals, actually the coordinates of PQR is denoted by alpha, beta, gamma, and they are given by this formula. Now, all these things you learn in conicoids. In my class as well, I have done these kind of questions multiple times. Now, feet of normals from it is given by alpha a square x1 divided by a square plus lambda. Beta is given by b square y1 divided by b square plus lambda. And gamma is given as c squared z1 divided by c square plus lambda. Okay, now see, when I'm saying that this is the feet of the normal, but there are 6 feet of the normal, but I have given you only the one set of the coordinate, right? X, Y, Z, alpha, beta, gamma. So where are all the other 5s? Actually, if you see closely here, A, B, C, what is A, B, C? A, B, C are fixed. They don't have multiple choices. X1 is also one fixed point from where you are drawing the feet of normals, from where you are dropping the normal space, right? But what about this lambda? The value of lambda, how many possibilities of lambda are present here? That gives the value of alpha. So if there is only one possible value of lambda, that means I'm getting only one of these coordinates, one of these feet. There are 6, right? P, Q, R, P dash, Q dash, R dash. So maybe one of them is achieved. But if I say that it has 6 possible values, then these formulas are all, or are giving you all of the these coordinates are giving you the coordinates of all of the feet of normals, all 6. Okay, so where this lambda is actually lambda gives you there are 6 possibilities of this lambda, right? Where, and that is given by this relation, where 6 values of lambda are given by the equation a square x1 square divided by a square plus lambda whole square plus b square y1 square divided by b square plus lambda whole square plus c square z1 square divided by c square plus lambda whole square. That is equals to 1. So I'm going to take that -1 here, and that's the case. So this is your second, this is your third. So third equation, if you look closely, this is a equation in lambda. What is the degree of this equation? 6. Here I have 2, here I have 2, here I have 2. So I'll take the LCM, I'll get 6. So 6-degree polynomial is formed in terms of lambda. That means this can give me 6 values of lambda, and those 6 values of lambda will give me the corresponding coordinates of 6 feet of normal to the ellipsoid, right? Now, there is one more information about equation of a plane. Now, equation of plane. Plane is PQR, is Lx plus My plus Nz is equals to P. Right? That's 4. And 3 of 6 feet. See, it's very easy now. Like this is what? This is a equation of plane PQR. That means P also lies on this plane. Q also lies on this plane. And R point also lies on this plane. Right? That's the case. That means whatever is the coordinate of P, whatever is the coordinate of Q, whatever is the coordinate of R, all these 3 coordinates will satisfy X, Y, Z in this equation. Right? What are the coordinates of PQR? See, these are the coordinates. Of course, it depends upon different value of lambda. But these are the points. These are the coordinates, right? So that means these points will satisfy my equation. And 3 of the 6 feet, 6 feet of normal lie on it. Lie on it. Therefore, L a square x1. So basically, I'm replacing this x, y, z with the alpha, beta, gamma above. A square plus lambda plus mb square y1 divided by b square plus lambda plus nc square z1 divided by c square plus lambda is equals to p. I'm writing it minus p is equals to 0. That's your fifth equation. I hope you get it. So what's happening? I'll explain it again. Only 3 points are lying on this, P, Q, and R. But I know whether there are 3 points or the other 3, all the 6 normals are given by, the coordinates of all the 6 normals are given by this. It just depends on different values of length. So for some value, or for, I can say exactly 3 values of lambda, these points satisfy this equation of plane, and that's what I've done. I've just substituted, right? Similarly, what I can do is, my target is to find the equation of plane P dash Q dash R dash. So let the equation of plane P dash Q dash R dash be L dash X plus M dash Y plus N dash Z minus P dash is equals to 0. That's my 6th. So basically, I'm looking for the values of these L dash, M dash, N dash, and P dash, and I'll substitute the value here to get the answer. But anyways, even if this is the equation, my substitution is still true. I can still say that these 3 points lie on this plane, plane number 6. So I can substitute these over here as well, because here for some different values of lambda, that will also satisfy. So I can say this is L dash a square x1 by a square plus lambda plus m dash b square y1 divided by b square plus lambda plus n dash c square z1 divided by c square plus lambda minus p dash is equals to 0. Right? Okay. Now, look at this carefully. All I'm saying is that 5th equation is true for some values of lambda, 7 is true for some values of lambda. But these are equations. Equation number 5 and equation number 7, 5 and 7. 5 is a cubic equation in terms of lambda. 7 is also a cubic equation in terms of lambda. And I know that those three values of lambdas are actually given by given by this equation. This equation is giving me all the 6 values. So the equation number 3, which gives me all 6 values of lambda, is separately given by equation number 5 and equation number 7. So if I multiply equation 5 and equation 7, that is exactly equal to equation number 3. Okay. So I'm not going to multiply. Instead, I'm going to only compare the coefficients. I can see a x1 square here, right? So if I multiply equation number 5 and equation number 7, then what will be the coefficient of x1 square when this x1 is multiplied together? So that will be the coefficient. So clearly, equation 3 is product of equation 5 and equation 7. Okay. So comparing coefficient of x square, y square, z square, we get, okay, that's x1 square, right? Yeah, that's x1 square, y1 square, and z1 square. So we are getting, what is the coefficient of x1 square if I multiply these two terms? I am getting L dash a raised to power 4, L dash, and then a raised to power 4 divided by a square plus lambda whole square, right? And over there in equation number 3, coefficient of x1 square is this, a square divided by a square divided by a square plus lambda whole square. This 2 gets cancelled. It gets 2. And it implies we are getting L dash, because my target was to find L dash, M dash, N dash, and P dash to substitute in equation number 6 to get the equation of required plane. So that would be L dash is equals to 1 divided by a square L, right? And similarly, if you equate coefficient of y1 square and z1 square now, so you will get value of m dash as 1 by b square m, and n dash is 1 by c square n. Okay. Also, you can compare the constant terms also, and p dash is equals to -1, because you see, if I multiply this side, it is plus p dash, but in equation number 3, we have a minus. So p dash is equals to -1, which implies p dash is equals to -1 by p. So you have to substitute everything over here. P dash I'm getting in minus, so it's better that if I take this over here, or even if I keep it over here, it will be positive. So what is this equation? Equation number 6. Therefore, equation of P dash, Q dash, R dash becomes, this is equation number 6. So value of L dash is 1 by a square L times x plus y by b square m plus z by c square n plus 1 by p is equals to 0. Hence, proved. That's the exactly same equation that is here. Okay, and this was for 20 marks. If you have done this question from P.N. Chatterjee, then it was very easy to solve. Next, we have this third question of 15 marks. Let's see. Find the equation of a sphere of smallest possible radius which touches the straight line this and this. Okay, so we have two straight lines here. Let's say this is one line and this is the another, right? So what will be that sphere? So this is in this sphere. What will be the smallest sphere of the smallest possible radius which touches both of these lines? See, first of all, it's very important to check whether these are intersecting lines in 3D. Because if they are intersecting lines, then we cannot proceed anywhere. This is not possible. To draw such sphere is not possible. So first of all, I'll prove that they are skew lines, right? Even if they are parallel lines. If they are parallel lines, not a unique circle, not a unique sphere is possible, then this sphere is also the sphere of minimum radius. This sphere is also the sphere of minimum radius. This sphere is also the sphere of minimum radius. So in that case, I'll not have a unique sphere. Unique sphere is only possible if these are skew lines. Now, I'll prove that skew lines later, but and if I get that these are the skew lines, after that what? After that, I'll find a line which is perpendicular, which is the shortest distance between the skew lines. So we have this topic also in analytic geometry, shortest distance between the skew lines, right? So let's say this AB is the line. Now, the smallest sphere is only possible if that AB line is the diameter of that sphere. So then after that, at the end, I'll find the equation of this sphere, which has AB as the diameter, which can be easily derived using the diametric form equation of the sphere. Okay, so let's go one by one. We have three parts. First, prove that it is skew lines. Second, find the line AB, find shortest distance. And number third, find equation of sphere such that AB is the diameter of that sphere. Okay, now given lines, I'll just mark them here as line number 1, and this is line number 2. Next. So let us check whether these are intersecting lines, first of all. So for that, take a general point on line 1 as, okay. So on the first line, you see, if I equate this with, let's say, R. So what is the value of X? I'll get 3R plus 3. So I'll get a general point as 3R plus 3 minus R plus 8 and R plus 3. That's a general point on line 1. And a general point on line 2 is what? Let's equate this next line with some R dash. So that would be minus 3R dash minus 3, 2R dash minus 7, and 4R dash plus 6. Okay. Now, if any of these points are exactly the same, see, basically, if the two lines are intersecting each other, that means there will be a point where these 2 points are exactly same intersection point. Let's equate them. If these points, see, it's like that. If these points are common for any value of R and R dash, then let's try to find it. Then first component will be same, which is 3R plus 3. See here, 3R plus 3 will be equal to minus 3R dash minus 3. Minus 3R dash minus 3. That's my third equation. Similarly, minus r plus 8 is equals to 2r dash minus 7. And r plus 3 is equals to 4r dash plus 6, which is 50. Okay. From equation 4 and 5. So from equation 4 and 5, I can solve for r and r dash. If those values of r and r dash also satisfy the third one, that means yes, these lines are intersecting point and will not proceed further. Let's check. So if I add that, it is 11 is equals to 6r dash minus 1. So your r dash is 2. Right. And if I substitute in any one of them, equation 5, and r plus 3 is equals to 14, that means r is equals to 11. Okay. Now let's see whether equation number 3 is satisfied. Now left hand side of equation 3 is 3 times r plus 3. 3 times r plus 3. So that is going to be 36. And right hand side of equation 3 is minus 3 times 2 minus 3. It's minus 9. Definitely equation 6 is not satisfied. It implies equation 3 is not satisfied. By these values of r and r dash. What does that mean? It implies line 1 and line 2 are not intersecting. Line 1 and line 2 are not intersecting. But you see, that doesn't imply that these are skew lines, because there is now one more possibility of being parallel lines. So I have to drop that. I have to check that condition as well. If they are parallel lines, then their direction ratios would be proportional. See, direction ratios are 3, minus 1, 1, minus 3, 2, and 4. They are definitely not proportional, so they are not even parallel. Now I can say that they are skew lines. So, also, direction ratios of line 1 and line 2 are not proportional. Are not proportional, which implies that line 1 and line 2 are skew lines. Now, if they are skew lines, what was the next part? To find the line AB, which is the shortest distance between both of them. Okay, so I'll refer to this diagram only. This is my line 1 and this is my line 2. So A, if I'm looking for the shortest distance, that means AB is perpendicular to both of the lines. So now I can write let AB is shortest distance between these two lines, which implies AB is perpendicular to line 1. Okay. What are the direction ratios of AB line? Direction ratios. Direction ratios of AB are. I can assume that A point, it is actually any general point, right? On the line 1. So this is a general point. So I can assume this to be A and I can assume this to be B, right? A and B are these points for some values of R and R dash. So let's use these values and I can find the direction ratios of AB line. How to find direction ratio of AB? That is x component minus x component, y component minus y component, z component minus z component. x2 minus x1, y2 minus y1, z2 minus z2. So if I subtract, it becomes minus 3r dash minus 3r minus 6 2r dash plus r minus 15 and 4r dash minus r plus 3. You can verify this from here. I have just done subtraction. See, it becomes minus 3r dash minus 3r and minus 3 minus 3. So that will become minus 6. And that's what I've written, minus 6. Similarly, you can verify these. One is line AB, another is line 1. What is it? What are the direction ratios of 1, which is given? Given 3, 1, and 3 minus 1 and 1. So if these lines are perpendicular, I have a relation between the direction ratios, right? So it implies 3 times minus 3r dash minus 3r minus 6 plus minus 1 times 2r dash plus r minus 15 plus 1 times 4r dash minus 4 plus 3 equals to 0. Solve this. You'll get 7r dash plus 8r is equals to 0. Also, AB is also perpendicular to line 2. Direction ratios of AB are still here, right? I'll use the same, but direction ratios of this line 2 is different. And that is what? That is minus 3, 2, and 4. So minus 3. This is exactly same. Minus 3 and 2 times 2r dash plus r minus 15 plus 4 times 4r dash minus 4 plus 3 is equals to 0. It will give you 29r dash plus 7r is equals to 0. So solving these two equations, so far I have 5 equations. So this is 6 and 7. Solving these 6 and 7, what I'll get? I'll get actually the coordinates of A and B. Solving 6 and 7, equation 6 and 7, r is equals to r dash is equals to 0. Therefore, what is A? A is 3, 8, 3 and B is minus 3, minus 7 and 6. You can verify this. What was the coordinate of A taken? This was the coordinate of A taken. And over here, A is already, R is already 0. So this vanish, this vanish, this vanish. What is it? 3, 8, 3. That's what I've written. Similarly over here, minus 3, minus 7 and plus 6. These are the points A and B. Right? These are the points. Now the last step, sphere with the smallest radius touching line 1 and 2 would be the sphere with the diameter AB. Okay? Required sphere is equals to sphere with diameter AB. Okay, therefore, diametral form of sphere is what? X minus x1, x minus x2 plus y minus y1, y minus y2 plus z minus z1, z minus z2 is equals to 0. Substitute these values. These are your x1, y1, z1, x2, y2, z. So you will get x minus 3, x plus 3, y minus 8, y plus 7, and z minus 3, z minus 6 is equals to 0. It implies I'm getting x square plus y square plus z square minus y minus 9z. And then it is minus 9 minus 56 and plus 18 is equals to 0. X square plus y square plus z square minus y minus 9z. It becomes minus 47 is equals to 0, which is required sphere. Okay, so divide your question in few parts and you can target the questions like this. Let's come to the next one. This was the last question, fourth C part, and it was from the section cone. Okay. If the plane ux plus vy plus wz cuts the cone, it is a plane cuts the cone in perpendicular generators. How can a plane cut a cone giving me lines, giving me two lines? So that is possible like this. If let's say this is a cone, if this is the cone, you imagine a plane which is actually passing through the vertex of your cone. If your plane passes through vertex of the cone, like at this point is common, then actually you will get two lines of intersection. That is this line and a line on the back side like this. Okay, so there are two lines and these lines are on the cone and they are on the plane as well. So the intersection is giving me two lines. Now they are saying that these are perpendicular lines. These are generators also. These are generator of cone. So that's what they are saying. Cone in perpendicular generator, then you have to prove a relation. Now what I'll do is let x by L. See, the plane passes through the vertex, only then it is possible. Plane passes through vertex means these two lines also passes through vertex. And what is the vertex? As you can see, it is 0, 0, 0. As you can see from the cone, what is the vertex? 0, 0, 0. So point lying on the line is 0, 0, 0. L, M, N, I have taken the direction ratios. So x by L, y by M is equals to z by N, be one of, or let's say be perpendicular generators. Be perpendicular generators in which ux plus vy plus wz is equals to 0, cuts the cone ax square plus by square plus cz square is equals to 0. Now the question is, why I have taken one line if I know that there are two lines? Because see, LMN, I have not given any value. So that means this LMN is an unknown variable. And the possible answers for this LMN are two possible. L1, L2, for M also, M1, M2, for N also, N1, N2. So there are two possibilities of the direction ratios. Those two set of direction ratio will give me two lines. And those two lines represent those two perpendicular generators. Okay. Now, if this is a line, which is a generator, so and it is also on the plane, that means it will satisfy the equation of plane. It implies Lu plus Mv plus N z is equals to 0, right? I'll name it as 3. And when a line is on the is on the cone, acting as a generator of the cone, then also its direction ratios also satisfy equation of cone. So that means AL square plus BM square. This is also a result. BM square plus CN square is equals to 0. Fourth. Now these two equations, use these two equations to find the value of L1, L2, M1, M2 and N1, N2, the two values that I was talking about. Okay. So from equation 3, what is value of N here? That is minus of Lu plus Mv divided by Z. Okay, sorry, that should be NW. That should be W. So this is the value of N. Put in equation 4. So substituting in equation 4. Substituting in equation 4, we get AL square plus BM square plus CN square. So N square, the value is of N is this. That is LU plus MV whole square divided by W whole square is equals to 0. Let's convert this into a quadratic of L by M. So it implies it is AW square plus I can write as CU square times L by M whole square plus 2UVC L by M plus BW square plus CV square. That is equals to 0. Okay, this is just the simplification. So now if I have equation in terms of L by M, let L1 by M1 and L2 by M2 be roots of equation 5. It implies product of roots. Product of roots is equals to L1 by M1 multiply by L2 by M2, which means what is let's use the formula. What is product of root? Minus C by A. C by A, so C means a constant, which is this. A means coefficient of L by M whole square, which is AW square plus CU square. So that means I can write it as L1 L2 divided by BW square plus CV square is equals to M1 M2 divided by AW square plus CU square. You can actually write N1, N2. See, I have obtained everything in terms of L1, L2 and M1 and M2 because I have eliminated N from the beginning, right? From equation number 3. What if I would have eliminated M from here? So I would have, I would get relation in terms of L and N. Okay, so I don't need to repeat that. Because of that symmetry, I can just follow one. If you do not if you have a problem in processing the unit, processing the symmetry that you are getting, so you can use this as well, because I'm using ABC and I'm on the other side, I'm using UVW. See what is the pattern in the first one. Let's say if I go with the first one. In the first one, it says B and C. Okay, so B goes with W square. So B goes with W and C goes with B. Okay, that's the pattern. Now, similarly, over here, what's the pattern? A goes with W and C goes with U. So what will be pattern in here? In the denominator of N1, N2? V, C, W. So basically, it would be with A and B, A, V and B, U. Okay, now it becomes easy. So A, V square plus B, U square. And this you can write by symmetry. Okay, now how that is going to help you? You already know that these ratios, see, direction ratios, possibility are 2 possibilities. I got the possibilities. I have taken them to be L1, M1, N1, and next is L2, M2, and N. These are 2 set of direction ratios, right? Now, I have a relation between these 2 lines. They are perpendicular lines. So what is the relation between the direction ratios of 2 perpendicular lines? L1, N2 plus M1, M2 plus N1, N2 is equals to 0. Let's use these values from here. Since generators are perpendicular generators, since generators are perpendicular generators, therefore L1, L2 plus M1, M2 plus N1, N2 is equals to 0. Substitute the value from here. Now you're saying that these are not the values, these are proportional, then why are we substituting? It's okay, you can equate it with k, and every time your value will be multiplied with k, right? So after that, what would happen? Because we have a, sorry, so because we have a 0 here, so k can be taken from common from all the terms, and that will vanish. So eventually that k will also vanish. So that's why I can directly take the values from the denominator. So that will be bw square plus cv square plus aw square plus cu square plus av square plus bu square is equals to 0. Let's take u square common. U square common means b plus c. B plus c, u square common, and a plus c in b square common, a plus b and w square common. This is exactly what we wanted to prove. That's the case. Okay, so that's proved. These 4 questions are from the analytic geometry that were in your 2022 paper, and these are very easy. So I hope this session was useful for you. Thank you so much.